back to the build track. Just a little bit of housekeeping. I wanted to mention that even though you're here, there's still great talks going on the other side. You don't have to worry about missing them. All of these talks, all the slides, all the video is going to be up on YouTube very shortly after the conference, so you can check out the conference website again to see anything that you might have missed. With that being said, our next presenter has a very impressive background. Charity Majors was the first infrastructure engineer hire at Parse. And then after Parse was acquired by Facebook, she went on to lead a team of production engineers at Facebook, solving some of the toughest infrastructure challenges in the world. She now is the CEO and lead engineer of her own startup, Honeycomb.io, and she's the co-author of O'Reilly's Database Reliability Engineering book. She is an expert in the world of building distributed systems that won't fall apart at 2 a.m. and wake you up. So please welcome to the stage Charity Majors.
Did you memorize all that? That's amazing. I don't think I can remember all that shit. Yeah, hi, I'm Charity. I cannot see anything except for the lights in my eyes, but I assume there are people out there. I do these things. You can tell I'm from ops because this is basically how I feel about software. I'm not completely against software, but I do believe that it causes problems. I'm a fan of running less software wherever possible. And the only good diff is usually a red diff. Personal preference. Did write a book. If you happen to have this book, you'll notice that it's a horse. It was not supposed to be a horse, but O'Reilly won't let you do mythical creatures. So I have stickers that will fix it to be a unicorn. I brought them with me. You can no one will ever know. It just has a little rainbow unicorn and rainbow mane. I got under control. So I do come from the ops side of the house, but there's like this association monitoring with like ops people, and I hate it. I have always hated monitoring. I've always been very much from the databases side of the house, where things are fun and have consequences. And we're not a monitoring company. And I'm not going to be talking about what we're doing at Honeycomb, but it's important to you guys are mostly software engineers, right? Some of my best friends are software engineers. It's fine. Sorry, I think that's hilarious. So let's start with the problems with monitoring. Gregory gave this great talk at Monitorama a couple years ago, a conference which I have categorically boycotted because, again, it's right there in the name. It's a monitoring conference. It's terrible. Monitoring is dead because they haven't changed in 20 years. They really haven't. We've gone through how many architectural revolutions and fashions and in the last 20 years, and monitoring is the same old, same old. It's like you got your dashboards, and you got your metrics, and some tags to group the metrics, and you got some checks, right? Every postmortem ends in well, let's create a dashboard so that next time we have this problem, we can find it immediately. Good theory, cool theory. This is hyperbole, this is his statement, not mine. I would say that it deserves to die, but it's not dead. No strong opinions to be had here. Any of you on call, generally speaking? I don't know why I'm looking at you. I can't see you. Thank you for that verbal response. Good to know. This is an outdated model. It's good for what it does, but it doesn't actually speak to the problems that we're having developing modern software. Most of which boils down to complexity, Now, you all are software engineers. I assume that you are nice computer scientists who went to computer science school, where they teach you things like Halstead volumes and cyclomatic complexities. Did they teach you that at computer science school? Okay, well, I'm a music major dropout. I did not know any of that shit until I started researching, because it always bugs me when people go, complexity, wah, 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 and you're using that word to avoid thinking very hard about what you're actually trying to say, right? So when I started throwing around the word complexity, I'm like, okay, I gotta understand this. So I did some research, but honestly, this is the graph that I'm going to draw for you. And I have a graph so you know that it's true. Okay, let's look at some architecture diagrams. There is the humble, wonderful, beloved-ish lamp stack. I cut my teeth on lamp stacks. I've been on call since I was 17, right? I grew up with these. And you're familiar with Parse, mobile backend as a service, kind of like Heroku for mobile. There's Parse's infrastructure diagram from a couple years ago. Now, bear in mind that cloud in the middle is a few hundred MongoDB replica sets running queries that developers all over the internet have just uploaded, and we get to just make run. And one of those clouds up there to the right is JavaScript from all over the world that engineers just upload, most of whom have never heard of a query planner. I'm just guessing. And we have to make them not only work, but not impact any of the other million apps that are running on the same hardware. So, fairly non-trivial system, but this is what I think our systems are trending towards, and that is actually the national power grid. Right? It's so much less this, which we can use our intuition with, right? And it's more, well, there are some problems that we're only going to see if we go hyper-local. A tree fell across the highway. You can't predict it. You're only going to see when you zoom way in. There's some problems that you'll only see when you zoom way out. Like the state of Arizona is down. And there's some problems that are going to be systemic and not really visible, like maybe all of the transformers that were manufactured by this power plant and replaced in 1983 are like starting to wear out really fast. The point of all this is you can't use the same way of thinking about your systems or you're gonna have a bad time. And this to me encapsulates the differences between monitoring and observability. Now, if you read Twitter, first of all, stop, don't. It's a terrible habit. Why are you still reading Twitter? Second of all, you'll probably have heard some well, it's just a marketing term. It's not, actually, because we have 20 years of best practices that we've developed for monitoring systems. Things like, you should not stare at graphs all day. Your system should inform you when something is broken so you can go check it. Cool. With observability, the best practices are the opposite. It's that you will drive yourself crazy and drive everyone to quit if you page them about every fluctuation and everything that might matter, because you only know if something matters in the context that you bring to it, right? Some things are spiky, and that's fine. Sometimes it's not fine that it's spiky, and you have no way of telling that programmatically. And the best practice is honestly just you have muscle memory. You ship a change, you go look at it. Did what you expected to happen actually happen? Did anything else just obviously jump out at you that it also happened? And there's just a handful of things like that where I don't want to fuck with the very robust set of practices that we've developed by just going, they're all the same. They're not. They're not the same. They're similar. They're first cousins. There's overlap, but they're not the same. Congratulations, you're now distributed systems engineers. You should probably ask for a raise. I hear they make lots of money. This is basically the patron saint of distributed systems because this is the first thing you have to internalize. Your shit is never working. Never actually up. So many problems exist right now, and if you're sleeping well through the night, you probably shouldn't be. Your tools probably aren't good enough. And you kind of just have to embrace it. It's fun if you like whiskey and gallows humor. The complexity that we're talking about is driven, it's more so all the way down, right? The proliferation of types of hardware, of types of software, of polyglot persistence. Remember when the best practice was the database? You have the database, and it is a terrible best practice to run more than one type of database because supporting them is so expensive for your team. Well, almost none of us get away with just one storage layer anymore because there's too much competitive advantage to be gained from some of the awesome advances in data storage. And where known unknowns used to be almost everything, I remember Second Life, when I was just a wee pup, like 2 or 3 times a year, something would puzzle us. It'd be like, all hands on deck. We have no idea what's going on. Something crazy, And the rest of the time, it was more like, oh, yep, that, gotta go fix that. Oh, yep, that again. We should get rid of this alert. Oh, cool. You'd be on call for a few months, and then you kind of had it. You had your repertoire. At Parse, the reason I started this company is around the time that we got acquired by Facebook, I was the first infrastructure engineer. I was there pre-beta. Took them through the Facebook acquisition to well over 1 million users. Around the Facebook acquisition, though, we were about 60,000 mobile apps hosted on our platform. And this is around the time that I began to realize with sinking dread that we had built a system that was effectively undebuggable by some of the best engineers in the world. And I tried everything. But we were losing ground. 50% of our time, 60, 70, was taken up tracking down one-offs, right? A user comes and they're like, Parse is down! So angry at you. And I'm like, Parse is not down, motherfuckers. Look at my wall of dashboards. They are all green. Which super helps, right? I'm just losing credibility the longer I argue with them about their experience, but I would dispatch an engineer or I'd go track down, and it's like I knew I was in for hours, sometimes days of tracking down these incredibly weird edge cases. It could be anything. And anytime as a platform that you have to think about one user, you failed in some way. So we were failing a lot. And the thing that helped us finally get on top of our shit was a combination of a tool at Facebook called Scuba, some stuff we wrote in-house, whatever. Fast forward, slice and dice on high-cardinality dimensions in real time, boom. We fixed it. We moved on with our lives. I'm an ops, on to the next fire. I did not even really stop to think about why it was so transformative. God, I'm just telling the story, aren't I? It's probably all in the slides later, so I'm just going to fast forward. But when I decided to leave Facebook, I was planning on just being an engineering manager somewhere, and I'm like, oh shit. Well, surely the rest of the world must have come a long way since I was last looking, right? Surely. And I went to every company's marketing website, and they all said yes, of course. Well, they haven't. So that is why I reluctantly did it. It's simple when you can ask the right question. It's incredibly hard when you can't, when you're dancing around and trying to knit together things that an NTP is off on this system, and so you can't even correlate time steps. It's insane. All right, it's insane. Monitoring versus observability. In monitoring, it's traditionally very black boxy, right? It is very biased towards outages, towards actionable alerts, right? You should never get an alert that you can't take an action on. Action, action, action. Observability is more well, maybe it's good, maybe it's bad, but I just need to ask a question. Maybe I need to understand it for business purposes. Maybe I just, I'm trying to understand the flow of my code. Doesn't matter. It's very much more about getting inside the head of your software and make it tractable and clear. Okay, also it's about drinking a lot. Full honesty. So the term observability comes from control theory. I've copy-pasted the traditional Wikipedia definition. I don't really know what that means. But I take this to mean for systems that if you've done your job well, you can answer any question. You can explain any state in your entire system without having to ship new code. Right? Without having to predict what questions you're going to need to answer. This sounds very simple, but there are a lot of things that proceed from this that are not entirely obvious. Things about storage formats and how you choose what data to throw away. Because believe me, we are all throwing away data all the time. You know this, right? Right? I hate monitoring, but I love debugging. Like any day that I get to launch strace and justify it is such a good day to be alive. I also think it's a little ironic. We spent like 10 years telling people, because of DevOps, monitoring is not just for operations. Well, yeah, it is. It is. It's how you operate a service, right? Just like instrumentation is how you develop a service. Doesn't mean same people can't and don't do both. It's just what it means. You can also kind of think of observability as the superset of monitoring and other types of asking questions. You have an understandable system when your team can track down any problem without having seen it before, and without that being painful. This should not be a dread, pit of your stomach, oh God, this is something new. We have to get rid of that feeling. Let's try some examples. Let's take a very, very familiar problem, like photos are slow. Why? LAMP stack era. I assume you all are just like, yep. Right? No? Yep. Excellent. I don't know what I'd do if you were like, no. You can monitor these things. They're so easy to monitor. Put a threshold on the connections to the database. Check the error output. It's so monitorable. Characteristics of these systems are they're very friendly to intuition. Dashboards are amazing. And this last one is subtler and funner, which is that the health of the system is pretty evenly distributed. So in other words, if your uptime is 99.5, about 0.5% of the time, somebody's getting an error. This is pretty easy to handle. It's like client-side magic that you guys do and I don't. And it's not that bad because it's evenly distributed. We'll get back to this in a sec. Best practices, blah, blah, blah. Let's look at the same question, taking some real examples from Parse and Instagram. What exactly am I supposed to monitor? I'm not quite sure. Also, I'm not done. I've got more. Oh, the Heisenbugs, the ones that keep coming until you look, and they just will never happen while you're looking. Why? And this one was one of my favorites. They're like, pushes down, and I'm like, pushes not down. Like, looking at it. Days go by. They're every day they're like, pushes down. No, really, people are really upset. It's not just the usual suspects, but it seems to really be down. I'm just like, what? I went and dug in and eventually realized that we had added more capacity, and we were using round-robin DNS, and it had exceeded the UDP packet size. No biggie. It's supposed to fail over to TCP. Did everywhere in the world, except one router in Eastern Europe, for whom push was down. Go figure. Do you realize how much time we spend talking shit about our users and not respecting them and not wanting to follow up on their problem reports because it's so painful to do so? It's such a high bar for us to want to go, oh God, I'll track this one down, What if we could just shrink that to just be like, click, 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 yep, cool. You know what the secret is? High-cardinality data. Okay, let me explain. High-cardinality. Imagine you have a data set of 10 million users. The highest cardinality is going to be unique IDs of any sort, because it's as many uniques as you have records, right? Somewhat lower cardinality will be last names, first names, right? Very low cardinality would be gender, and presumably species would be very, very, very low, like 1. So what kinds of information would you just, casually with your big computer science brains expect might be the most useful? High cardinality. Well, Dashboards can't do that. Metrics can't do that. I'll explain why in a few minutes. Like, really, the key to getting a handle on our shit at parse was almost entirely just the ability to break down by 1 in a million app IDs, and then break down by any combination of any other values. That's it. But suddenly, it's like we had auto-generated all of the dashboards for all of parse for each user, right? Instead of getting the top 10 list that you get if you're lucky, we were just like, okay, Disney, you're doing 8 requests per second. Well, we're doing 100,000 requests per second. You're never even going to show up, right? Your errors are never going to show. Well, you break down by just Disney's traffic, and suddenly you go, oh, yeah, your latency is going up. I see. Oh, you deployed a query. Looks like it's timing out in the login endpoint. Did you deployed a query, or that your data set grew by another 10 rows, and suddenly you went from 29.9 seconds to 30.1 seconds, and now you think it's all down. There's so many things it could possibly be. You need to be able to inspect the actual reality of each user. These are all unknown unknowns. I feel like the future of debugging for all of us looks like this infinitely long tail of things that almost never happen. Except that once. You can either think this is awesome or terrifying, probably based on how good your tools are. Characteristics of these systems. Unknown unknowns are most of the problems. Or rather, if you find yourself in a system like this and you're still going, this again, oh, this again, you have different problems, and I'm not here to help you with those today. You cannot model the entire system in your head. Dashboards are often actively misleading because everything spikes at once, or everything drops at once. There's no causality, there's no correlation, there's no sense of context and where in time and space you exist. The hardest problem is often identifying which components to debug or trace. If you have a system that's self-referential that can loop back in, a single node or container or database instance that's running a snapshot on a live volume can infect every single node, right? It can be very hard to tell what it's emanating from. And this last one, I love this. Health of the system is irrelevant. Doesn't matter. I'm exaggerating a little bit, but not that much. Imagine if you're in AWS and if you've done your job, you're distributed across some availability zones, and if one goes down, you don't even get woken up. Your users can never tell. Meanwhile, all your dashboards are red, and you're 25 or 33% down. Do you care? I don't want to care. I deeply don't want to care. On the other hand, imagine that imagine your entire system is doing 4 requests per second, right? But they're all Disney, 4 out of 8. You gotta care. You actually care about the health of each individual event and every high-cardinality slicing and dicing grouping of these. This is also relevant because in distributed systems, it tends to be not, oh, everyone has the same experience, they're all using the same components. It's more like if your reliability is 99.5, well, most people think that you're 99.999% up, and everyone whose last name starts with B-H-E thinks you're 100% down. Or something that's localized. We do all this fancy-ass shit to partition and fault tolerance, but what we've done is also create a lot of little pockets that can go very unnoticed, for whom experience can be very bad. And if you can't tell the difference, right, if you can't slice and dice, if you can't both zoom in from, I have everything, I want to find where the problem is coming from, and then you need to pivot back to, okay, no, show me everyone who shares this. Who else is experiencing this? If you can't do that, you have 2 choices. One is just be comfortable with kind of sucking. And I do not say this with judgment. That should be your first choice, if you can get away with it. Because not sucking is very hard and expensive and will take a lot of time and energy. I'm in no way saying you should definitely not suck. Do I sound judgmental? Those are your options. You can either suck, or you can develop the tooling, or you can throw bodies at this problem. It will work for a ways. Quite a ways, actually. Usually. It depends. Sorry, I'm not really good at delivering good news. Best practices. It's all about instrumentation, right? It's so much about developing those muscles. This is what separates the senior engineers from everyone else. Is having operational instincts and knowledge and just the reflex. I wrap every call, right? You start at the edge and you work your way down. Events, not metrics. I think the rest of this talk, I'm just going into each one of these in a little bit more detail. Events are powerful because, all right, so there's two meanings for the word metrics. There's the generic noun, meaning things I use to understand my business. That's not what I'm talking about. I'm talking about the metric, which is this thing that we devised back when hardware was incredibly expensive. We were just like, oh my God, I cannot write a log line to my 64 meg hard drive. So the metric was born. The metric is a number. That's it. It's a number. And then, in order to find and group our numbers, we append some tags. Well, you cannot use high-cardinality values for those tags because of the write amplification. So you're limited to the number of tags that you can have, which is typically in the hundreds. So you're going to want to assign some of them to system details. If you have more than a couple hundred hosts or containers, you can't use the ID as a tag either. So you spend them wisely. Anyone who spent any time in the space has blown out their key space by just trying to put useful data in their time series database. How dare they? I have a thing against time series databases. Events are powerful because they pack a wallop. They tell you not only a number or a bunch of numbers, but also these all describe the same event. And all of these things were true at once. And if you think about the many hours or days of your life that you have lost to trying to correlate things across different systems, I feel like you're just going to have a gut feeling for how important this actually is. When I say events, I basically mean structured logs that don't necessarily write to disk. In fact, please don't write to disk if you don't have to. Disks are terrible. Disks also cause problems. But structured data, yeah, you want that. The difference between these unstructured strings that you all like to put in your logs and structured data is the difference between grep and all of computer science. And you went to computer science school, so fix your fucking logs. Sorry. You have to test in production with these systems a lot. And testing in production has gotten a bad rap, mostly, I think, because of that really hilarious meme that's I don't always test, but when I do, I test in production, Funny meme, but in fact, you test in production whether you admit it or not. In fact, staging is like the equivalent of the tests, right? You can test some things, the easy things, the really dumb things. You do not know how your code is going to perform in production until it's in production. And I feel like a better metaphor for code in production is the fourth trimester. You know how every other mammalian species, babies are born, they just go toddling off to the eat, real food? Well, human babies don't. I don't know if this is news to you, but they come out extremely helpless. And they can't do much for themselves. And this is how you should feel about your software when you're pushing it to prod for the first time. You should wrap it up in a nice little feature flag so that it does not get hit by all those terrible users out there who don't understand how cute your baby is. It's very cute. Just not to be trusted. But you should, and this advice is for people who have services that are mature enough to have users that count on them. Again, if you don't have to care about quality, please don't. It's hard and time-consuming. But if you do, then I recommend things like canaries. Roll it out to 10% of people. Facebook always rolled it out to Brazil for some reason. I never found out what they had against Brazil. They give it to 10% of Brazil. Okay, looks okay. Depending on how much engineering time you have to devote to this, I personally find that almost everyone spends too much time trying to make staging work, because it's a pain in the ass, and not nearly enough time thinking about guardrails for baking in and maturing their code like a fine wine in production. This last one is your reward. I'm not gonna lie, the observability tools, tactics, techniques, they ask a little bit more of us up front. If you can get away with some intuition and some monitoring checks in your LAMP stack, do that. But when you reach the point where you're just like, I'm dying, or even before then, and you need to invest in observability, your reward is you don't need to page yourselves that much. Maybe the big 4, right? Latency, request rate, errors, and possibly saturation. And a couple of end-to-end checks that traverse the critical path around what makes you money. That's it. If you trust your tools to give you the answers, no matter what it is, quickly, every time, you can get rid of all of these terrible things that we're all just kind of embarrassed about and don't talk about, like the fact that we get paged by, we get a page bomb of 50 unrelated things, but we know that it means that it's Redis. This is not science. I'm going to skip through it because I really want to at least save some time for questions. The one thing that I want to talk about sampling real quick. Oh, yes. Here's an example of some potentially useful data, all high cardinality. I wanted to talk about, oh yes, dashboards, define your dashboards with your dashboards. That's a terrible pattern. Every dashboard is an artifact of a past failure. Oh, right. Okay, so sampling, and then teams, and then I'm done. So every time that you're understanding a system, you make a choice about what to save and what to throw away, and you throw away far more than you save. This has been abstracted away from a lot of people by time series databases, which is part of why I hate them, because what they do is they select an interval, like a second, and they smush everything that happens over that interval into one number. They're just like, only one thing ever happened. That is a lie. Not only is it a lie, it's a dirty lie, because you could never ask new questions of that data that you smushed and threw away, right? You don't have access to those events anymore. Once smushed, you cannot unsmush, right? So they're throwing away everything that's happened to give you high-performing metrics. And I do not think that you can even call that observability if all you have is these time series aggregates, because you can't ask a new question about what happened. You have to have the event. You have to have the request. You have to have something that you can trace back to a real user's experience. However, nobody in their right mind is going to pay for an observability stack that is 100 times the size of production. So, if we're going to choose events, we have to choose what to throw away in order to get that nice, fat, rich event. And I recommend sampling. Now, sampling is big with data scientists. They're just like, well, obviously, you sample everything because counting every single thing is impossible. Why would you even try? I like these guys. It's cool. But we're not used to it. Like, we don't have the muscles, we don't have the language, we don't have the, the habits associated with this. And a lot of people they're like, oh, but that one rare event, what if I don't have it? I need to keep everything. Because, I don't know, maybe I bill off of these logs. First of all, stop that. So many people do this. Like, your billing logs and your operational data must not be the same thing, or you will do very bad things in one direction or the other, or probably both, really. Different strokes for different folks. But you don't want to sample dumbly, right? You absolutely have the ability to keep all of things that happen rarely, keep, most of things that happen, semi-commonly, and sample heavily the stuff that almost never matters, or that to rephrase, only matters in aggregate, right? Because when things are good, what do you care about? All you care about is the shape, the direction, the curve, right? What's happening on average. It's only when something goes wrong or you have a specific question that you want to go in and find that needle. And in your brain, try to reframe it away from, I must find that thing, to I must find a representative instance of that thing, or something that is affected by that thing. That's all. It's a pretty easy mental habit. So like for web data sets, 200s, right? Very easy to sample. Very good to sample heavily, except to endpoints that only get hit rarely. Keep all of those. Keep more of them. I don't know. 500s, keep them all, right? When the site goes down, you can rely on the server side to cut the top off the mountain. It's fine. But under normal circumstances, you want all those details. For databases, often, like parse, only time a delete got issued was when somebody was deleting their app. So we kept 100% of those, right? Inserts, I think we kept close to 100% of all those. But like selects, well, no, not really. Sometimes if we were like, so you get what I'm saying, right? And I feel like the curating sample rates is the new and vastly improved curating alerts, right? It's not waking you up. It is something that you don't always have immediately what you want, but over time, oh my God, it's a great way to deal with this data. Oh, more ranting about aggregates, yes. Here are some examples of just things that get really easy with this kind of a system. You notice how it's like, so I feel like when you're debugging with dashboards, it's not really debugging. You're not doing science. You're pattern matching with your eyeballs, right? You're just kind of like flipping through them like, is it that one, is it that one, is it that one, is it that outage, is it that one? This one looks, you know. And the thing is that it takes so much submerged intuition and sort of, you know how the person who's the best at debugging the system is always the person who's been there the longest? Now, I love being that person because I have a hero complex. It's not good for me. But it's kind of demoralizing to everyone else. It's not very democratic. It's kind of shitty for me, too, when I'm in Hawaii. It just doesn't scale. So I've now had the experience 3 times in a row of being on teams where that was not the case. Where after 3 to 6 months after joining the team, the best debuggers were not the people who had been there the longest, they were the best debuggers, or the people who had written those services, right? And I've thought a lot about why and how this was, and I think it's because the old style with dashboards, it just asked so much of you to model so much shit in your head, and like, especially when you're like reading lines of code and you're like, you have your mental model of how it takes so much, and you have to be exposed to so many outages and so many things to just get that gut feeling of, I know what it is, right? You jump straight to the answer, and it's the greatest feeling in the world, unless you can't do that, and it's the worst feeling ever. But it doesn't take you there. Whereas this kind of debugging, it's more like the way that we do business intelligence, right? Instead of jumping to answers and sifting through answers, you're just asking a question, looking at the answer, asking a new question based on the answer. It's like you're following the data where it's taking you, right? And following the breadcrumbs where they take you, while it feels more open-ended and terrifying in the beginning, it is actually so much more secure, and you're just taking so much of what you need to know about the system out of your intuition and into the realm of your tool, where you can interact with it. And it's mind-blowing. This is another reason that I started Honeycomb, because I feel like this has to be the future of engineering. You know, I've seen too many teams just burn their people out, lean so heavily on their senior folks, and it's just toxic. And it's just so much easier. We can just ask a question, just like follow the trail. It's not that hard. It's like a puzzle. It's super fun. Anyway, the thing to remember is like, our users don't give a shit about our nines and our fancy metrics. Like, they care about their experience. And if our tools don't place experience front and center, then they're the wrong tools. Test in production. Software engineers own their own services. Services need owners, not operators. I feel like the center of gravity is moving absolutely relentlessly towards a generalist software engineer who sits in the middle of all of these internal, external services and APIs, just desperately kind of trying to get something to work. It's all right, you have a glorious profession. And ops people like me, we're not going away, but we increasingly live on the other side of an API. And you can't always run over and bug us. And when I talk about software engineers needing to learn ops, it's with this in mind, that it is empowering, it is it's reassuring, well, to everyone around you, but also to you. On-call responsibility do not have to be death sentences or life sentences, or really unpleasant at all. And I know that a lot of people have scar tissue and bad experiences, but this can be experienced as a very empowering and a very fun thing. And yeah, that's my view of the future. Anyway, I think it's table stakes. I do not think that operational skills are a nice to have anymore. You would not hire an ops person who couldn't write code, right? Not optional. It's part of building software. And I'm going to through all of the things that talk about the development process and how it's observability driven, all this shit. It's just automating ourselves out of a job. And I'll end on that. Woo! Thank you. Any questions if we have time? I'm happy to talk afterwards, too. Just come find me. Also, I have stickers that say very rude things about computers. So I'll put them out there, and you can take some if you want some.
So on the topic of testing in production, I think you're able to do that if all of your customers are end users, where they're, a subset of them will probably complain to you, but there aren't any other.
You should definitely have users that you can test on, like your friends.
Well, that. But what if you're a company that has a lot of very stringent SLAs with other companies, and if you try to test in production, you're going to actually cause a hit on your SLA? What do you do in that case?
Well, so first of all, testing in production a lot of it is isolating your critical path, making it as dependent on as few things as possible, right? As resilient as possible, as loosely coupled. You want so many things to be able to fail gracefully, right? That is where the bulk of the good engineering is done. And then you create, you cannot have to care about all users equally. You cannot. If you have to create fake tiers of users, or free tiers of users, or something like bots, you have to have people that you could experiment on, is the high-level answer.
So you talked a little bit about sampling the common use case and saving everything from the rare use cases. How do you are you able to decide what is common, what is rare? Are you having a machine figure that out for you?
It depends. Usually you have some knowledge of your systems that you can start with. And you're never going to get it completely right, but you usually kind of know where to start, or you just pay for 2 or 3 times as much as you know you're eventually going to want to, and over time you just kind of prune it. Dealing with unknown data sets is obviously categorically more challenging than dealing with ones that you know. I'm a big fan of the way that we do events. You can have data sets that are 300, 500, thousands of dimensions wide. We don't want to incentivize people to not put any data there. We want them to put as much possible, because who knows what's going to be valuable, right? So, yeah, it's always a trade-off. Thanks.